Hello, it's Keith here, and this is lesson 6 of the so-called Chibifighter series, in which we look at bits of code from my little Chibifighter game, which is a sort of parody of Street Fighter 2. What we're going to look at today is the code that handles the player movement. Now, the player movement code also handles unavoidable facts like gravity. If you get pushed off the screen, like there, I've been pushed off the screen, then you'll get pushed back in by the edges of the screen. It also handles things like the player detecting the player's key presses, and it actually controls both the human player and the CPU player. The way the game works is the CPU player will decide what it wants to do, but then it passes its instructions as a key press. And the reason for this was I wanted the game to be able to be two human players, two computer players, things like that. That seemed like the most logical way to do it. So we're going to go through this so-called UpdateFighter routine today, and we're going to take a look at what that contains. So let's go over to our code and let's check it out. Okay. So here is the start of the UpdateFighter sequence. Now you'll see that this is actually run twice. The first time here is for the player sprite, IX is pointing to the player, and D here is being loaded in from the joystick here. Now the second time, the UpdateFighter routine is being run with IX pointing to the CPU sprite, and this time it's the AI that is loading in into D, and so that is the simulated joystick. And basically this means that the same routine can be used for both. So when we start here, the first thing we're doing is we're checking if the player is currently hurt. Now the hurt counter is basically if you've just been punched, your life will deplete for a few ticks of the game, and during that period you can't actually move. And so in that case we've got a special routine. Now what we're doing first is we are decreasing the current amount of hurt. So if it was 5, it's now down to 4, and when it reaches 0, the player will no longer be being stunned by that injury. So that's what we're doing there. We're then loading in the animator byte. Now the bottom nibble of the animator byte is the current animation. The top nibble is the tick of that animation. So we only want the bottom nibble, and we're comparing it to 6, which is the hurt animation. This is basically checking if the player is currently showing the hurt animation, and if not, we're showing the hurt animation there. So that's why we're doing that. We need to make sure what the current animation is, because if we just loaded 6 into there, we would reset the tick, and that would reset the animation, and that wouldn't work very well. Now in that case that the player is hurt, we're also decreasing the current life of the player and updating the life bar. So that is the injury occurring there. Now in that case we don't want to process any directions because the player is stunned and can't do anything. If the player can do something though, we're going to process their actions. Now the first thing we're doing here is checking bit 5. Now that is fire 2 on systems that have 1, or space if we're key controlled, that kind of thing. But so that this game was playable with only 1 fire button, I decided to basically simulate one of the other key presses. So in the case that fire 2 is pressed, we're effectively pressing the up and fire buttons here. The first bit there, bit 0 is up, and bit 4 there is fire, and so up and fire is effectively jump. So fire 2 is simulating fire 1 and up, which is jump. That's what that's doing there. Okay, now what we're going to do next is we're going to handle the key timeout. Now there was a bit of a limitation of the early version of the game where if you held down fire you would just endlessly punch. The enemy couldn't get close to you because you were punching all the time, and nothing worth playing happened. So to stop that, we've got a timeout on punching. And so basically what we're doing here is we're checking if the player currently has the fire button held down, and if they don't, then we are depleting the key timeout. So this is basically saying, well, they're not holding down fire now, so the timeout is going to go down. Once it reaches 0, they can press fire again and effectively punch. So that's what we're doing there. We're checking if that timeout should be depleted. What we're going to do next is we're checking all of the bits and seeing if any key presses are occurring, and if they're not, we're going to skip. Now what we're doing here is we're going to update something known as the key buffer. Now there's a buffer of up to 8 key presses that were recently pressed on the system, and this is so that we can do the combos. There is only one combo in the game, which is a fireball move. We'll see that code in a moment, but to be able to do that we need to compare the key presses that have been pressed and see if they match the fireball move. And so what we're doing here is we're updating the count. The count can only go up to 8, that's the size of the buffer, so if we're up to 8 we are overloaded, and if we're not, then what we're going to do is we're going to store this key press into the new position within the buffer here. So we're getting the player's buffer. There's one buffer for each player, and we are basically checking here to see if the current key is already in the buffer, and if it's not, we are adding that new key into the buffer and updating the count accordingly. There is a timeout on the buffer as well. This basically means that the player has to do all of the moves in the combo within a certain period, otherwise it will reset back to empty and they would have to start the combo again. So that's what that requires. Now what we're going to do next is we're going to deal with the punches and the kicks and things like that, and during this sequence we're using C as the sound number. Now 0 means no sound effect, anything else means we're making a sound effect. And so what we're doing here first is we're checking if the player has pressed the fire button, which is bit 4 in the D register there. Now if the player has pressed the fire button, we're now going to check the timeout, and if the timeout hasn't reached 0, the player has punched or kicked or something recently, and we're not going to let them do that again for a little while. And so what we're doing here is effectively rejigging the D register so that they haven't actually pressed any keys at all. So we're punishing them for trying to punch again too quickly. So that's how we're compensating to stop them doing that. Now what we're doing here is we're checking to see if that combo has been done for the fireball move, and so what we're doing is we're getting the address of the key buffer for the player's recent key presses, and we're getting the fireball move template, and we're running compare sequence. Now this will return a 0 if there's a match on that sequence, or a non-zero otherwise. Now if there's a match, then what we're basically going to do is we're going to set the sound effect to number 2 and the animation to number 8, and we're just going to jump and go ahead and do that. Now the compare sequence routine you can see up here. Now what this does is it will load in a sequence in this format here. The first byte is the count of bytes in the sequence, and then the following bytes are the templates for the key presses we're looking to find. So here we're looking to get a down, followed by down and right, followed by right and fire here. Now the problem of course is the direction the player is facing, and we're going to have to cope with that. Now the first thing we're doing here is we're loading in the byte count there, and then what we're doing is we're loading in the directions that we are looking for, and if necessary we're going to flip them with this do joy x flip ix here. Now where is that? It's just here. So what this is doing is checking if the flags of the player, and if the player is facing left and the player has pressed left or right, we're basically flipping the left and right key presses so that they're opposite. So if the template contained right but the player's facing left, we will convert that to a left, and that's what we're doing there. And that is so that when we compare to the key presses the player actually pressed, the fireball will work in both directions. Now in the case that there's no match, then we're going to give up. Otherwise we're going to repeat until we've got the end of the sequence, and if we get to the end of the sequence and they're all matches, we'll return a Z flag, otherwise we'll return a non-zero flag, and that is how the compare sequence is being used to cause a fireball. So that's what we're doing there. Now once we've done that, we're now going to deal with the jumping. So we're checking the up button here as well. We've already checked to see if we're firing, so we know that the fire has been pressed if we've got to this point in the code. We're now checking the up. What we're doing next is we are going to basically we're going to use the E register as the animation here. So we're loading the animation 4 into E here, and then what we're going to do is we're going to check the current position of the player. Now the Y pos is actually a three-dimensional axis. We've got X, which is across, Y, which is for jumping, and Z, which is for in and out of the screen on the floor, if you will. So if the Y is basically anything other than 152, then they must already be in the air somewhere, and they can't jump mid-air. They have to be on the ground, obviously. So we're checking to see if the player is currently on the ground there, and if they're not, we're going to skip the next section. If the player is on the ground though, we're going to set the Y move to 30, and this is a time-based update to the Y position. So we're basically going to update the Y position for 30 ticks here, and in that case we're going to skip over to the apply routine. Okay, so that's how we're doing a jump. The next thing we're going to do is we're going to check the down key here, and this is going to cause a block if we press fire and down. So in that case, what we're doing here is we're setting the animation to 5, which is block, and we're setting the sound to 0. We don't want to make a sound in that case. Otherwise, what we're going to do next is we're going to do either a punch or a kick, and in that case we want to set the key timeout, because this is going to stop us constantly punching or constantly kicking, which would be cheating. So we're doing that there, and then what we're doing here is we are loading in the sound effect and the animation here for a punch. Now this would be apply if just the fire button is pressed. So what we're doing here is we're checking left and right, and we're seeing if neither of those bits are pressed, and if they aren't pressed, we're going to skip over the next section, because the next section will change that to a kick. So it will change the animation number in E to kick there. Animation 3 is kick, animation 2 is punch. So that's how we're defining which one to use. Now, the apply routine is the last sort of part of the chain in all of these cases. What we're doing here is we are loading in the selected animator, and if it's not 0, we are setting the animator here, updating the animation if we've been given a new animation value. And then we're checking the C register, and if we've been given a value other than 0, we are running the play SF6 routine of the Chibi Sound Pro driver, which is effectively an instantaneous instrument fire on the channel. So that is effectively causing an instrument to play there, and that's what that will do there. So that's what that will do with the value in the accumulator. Once we've done that, if we've handled the key presses, we're now going to skip to joy done. In the case that there's no key presses, what we're going to do is we're going to update the key timeout. So what we're doing here is if the key timeout is non-zero, we are decreasing it by 1. Remember, this is for the combos, so that's so that the combos can be processed. Now, if the player isn't firing, then we're now going to process the direction keys. So what we're going to do is we're going to do up, down, left and right. So what we're doing here is we're seeing if any of the directions are pressed, and if they aren't, then we're going to jump to this branch here. So if the player is pressing the directions here, what we're going to basically do is we're going to check if the current animator is animator 1. Remember, just the bottom nibble is the animator number, top nibble is the frame number. So we're seeing if the animator is currently set to 1, and if it is, then we don't need to do anything. But if it's not, then what we're going to do next is see if the player's in mid-air, because if the player's in mid-air, then we don't want to show a walking animation. They'd be walking in the air otherwise, so that'd be a bit weird. So we're checking if they're on the ground, and if they're not, then we're going to skip over. But if they are, then what we're doing here is we're setting the walking animation to show the ground walking there. Now, if the player is not walking, what we're going to do in that case is check if we were previously showing the walking animation here. And if we were, then what we're going to do is we're actually going to reset it to 0. This means basically they've stopped walking, so we want to stop showing the legs moving away. And so we're changing to 0. Animation 0 is basically no animation, it's just a static image. And sprite number 0 is basically the standing character doing nothing. So that's what we're doing there. Okay. What we're going to do now is we're going to load B and C with the X and Y position of the player, and we're actually going to move the player around. At the moment we've just handled the animations. Now we're going to physically move the player. We're loading B with the X position and C with the Z position. Now the Z position is relating to the ground, so this is up isn't jumping, up is moving in and out of the screen, if you will. We are basically checking the Z position, and we are making sure the player can't go below 0 on the Z axis here, but if they aren't, then we're decreasing the Z axis. The down key is doing the same. Basically, we are checking if they are at Z position 16, which is the front of the screen, I guess. And so if they try and press down and they're already there, they can't. Otherwise, we're increasing the Z position here. We're then doing the same for left and right. I mean, this is basically very similar to the simple series example here. So if they're pressing left, we're basically decreasing the B position, and we are setting the flags for them to face left. A flag of 1 flips the sprite to face left. Now, pressing right will increase the B position and set the flags to 0. Now, you'll notice there's no range checking there, and that's because we've got some routines to bounce the player back in coming later, because the player doesn't just go off screen because of their own volition, they also go off screen because they've been punched and been knocked off screen. So we're going to see that in just a moment, and here it is. So what we're doing here is we're taking the B position and we're comparing it to the minimum X. Now this is the virtual coordinates system used by my Mintile graphics routine here, and if the player is off the left hand side, we're nudging them to the right, and if they are off the right hand side, we're nudging them to the left, basically forcing them back in gradually over time. So if they're like jammed off the screen, they will slide back in. It gives a nice sliding effect when they're stunned, which I think quite nice. And then what we're doing here is we're updating the X and the Z positions. The Z position, as I say, is in and out of the screen. The Y position is jumping up and down. I was going for a Teenage Mutant Ninja Turtles Streets of Rage Renegade type of thing, where the floor had 3-dimensional depth. I prefer that. I thought that was more interesting than the Street Fighter 2 lack of depth. I thought it made a more varied game and a better example. So anyway, there we go. That's all we're going to be covering today. If you've liked what you've seen, please like and subscribe and all of that kind of thing. And as I would say, I do have a book. And if you want to support me, you can buy my book. I have two now. The first one's Z80 6502 68886 and ARM. And the second one, ARM Thumb 6809 65806 65816. Sorry, PDP-11 and Risc-V. So if you want to support me, you can go ahead and buy those. Anyway, hope you've enjoyed what you've seen today. Thanks for watching and goodbye.